Welcome to lesson 4.5, naming polyatomic ionic molecules. As a reminder, make sure to title your notes this. And at the end of the video, these are the 3 things you should be able to know how to do. So please pause this video and make sure your title is written down as well as the key ideas or the objectives for lesson 5.4. So in our Zoom class, as part of our classwork today, I had you compare monatomic ions, something that we worked on Nearpod lesson 5.2 and 5.3, and versus polyatomic ions, right? So this is something we're going to add on to the previous lessons today. And you might have noticed that the main difference between monatomic and polyatomic ions is that polyatomic ions are a group of elements. So there's more than one element that when they're all combined together produce an overall positive or negative charge. So this is essentially what a polyatomic ion is. Here is an example of a polyatomic ion. I have 1, 2, 3, 4 elements, and when they're all combined together, they will have a charge of 1 minus, right? So this is something that chemists often memorize, but don't worry about memorizing the charges of these polyatomic ions. I'm going to give you a reference sheet to identify what are the names of the polyatomic ions, their charges, and their formula. And as we go through this lesson, we're going to be able to try to find out, okay, if I have this polyatomic ion and it needs to combine with something like Mg, what will be my formula and what will be my name, right? So whenever we're combining new ions together, we end up with a new ionic molecule that we can use for something. Right. This is kind of the same as what we learned in the previous lessons in lesson 5.2 and 5.3. It's just that in those lessons, we only had 2 ions combining. So for example, here we have Mg combining with 2 Cls, right? So Mg, whoops, wrong color. Mg, as shown here, is this particular element or ion has a charge of 2 plus, right? Meaning it's going to want to give 2 electrons away. But chlorine, Cl, only has a charge of 1 minus, meaning it only wants to gain 1 electron. So since chlorine only needs to gain 1, Mg is going to donate 1 to Cl and 1 to the second Cl. That's why we need 2 Cls in this formula. So we're kind of doing the same thing as that, figuring out the charges. How are they going to end up being MgCl2? In addition to that, how do we end up with the name magnesium? Right, this comes from the periodic table. And then the second name, chloride. So for your notes, you only need to write down this definition located here. Something that also helps me is to draw out a couple of examples of these ones, maybe just 1 or 2. Okay, so let's figure out what we can do if we're given the name of a polyatomic ion, like magnesium hydroxide. How do we figure out its formula? Or how do I figure out what the element symbols look like? So I know that if I check the periodic table, magnesium is going to be Mg, but how do I look up hydroxide, and how do I know what the formula is going to look like when they combine together, right? So you're going to see that most of these steps are the same as when we were doing Nearpod lesson 5.2. Right, so first we're going to identify the charge of each element as an ion using both the periodic table and the polyatomic ion chart. So I'm going to always link these 2 things for you if you're ever working with polyatomic ions, right? So let's first figure out what the charge of Mg is in case you don't remember. So if I look up magnesium, so on my periodic table, I'm going to have to look up the name magnesium. So magnesium is here. And it has a charge of 2 plus, right? So in step 1, doing step 1 right now, Mg has a charge of 2 plus. The second thing I need to do, also in step 1, is to find the charge of hydroxide, right? And if I look up hydroxide in the periodic table, it's not going to be there because there's nothing called hydro. Well, it sounds kind of like hydrogen, but hydrogen would be hydride at the end, right? Not hydroxide. So if I have a polyatomic ion, I can usually tell if it ends in 8. So for example, if the ending of the name is 8 or ites, right? This usually helps me out and tells me that it is a polyatomic ion. Or if it ends in xide, right? Okay. So because this is a hydroxide, it is one of the polyatomic ions. So I'm going to check my polyatomic ion chart for that. And it looks like this. So I'm going to look for the name hydroxide. So notice that in this ion chart, I have the name, and next to the name, I have the formula and the charge. And up top, it tells me the charges of all of them. So ammonium is the only one for the charge that's up top. And we're going to look for the name hydroxide. So I'm going to scan through, see hydroxide here, and it tells me that the formula is OH with a 1 minus charge. So I'm going to go back to this. So hydroxide is actually OH with a 1 minus charge. Right? So that's not true anymore. So now, just like before, to do step 2, I'm going to add up each element's charge until they combine to 0. So Mg has a charge of 2 plus, hydroxide has a charge of 1 minus, right? And eventually, just like before, I want the numbers to match but be the opposite of each other. All right, so these two numbers of the charges need to be the same, but this one needs to be positive, this one needs to be negative. All right, so if this is already 2, I probably want to add one more to this. So I'm going to add one more hydroxide ion, OH 1 minus. So if I add up these two charges, I'm going to end up with 2 minus, and with just one of these, I have 2 plus, right? So this right now is step number 2. Now that they're opposites, they're going to automatically add up to 0. So to find the formula, I need to figure out how many of each element or ion I use to get to that 0. So here I only used 1 Mg, right? So it's going to be Mg 1, but I don't need to write that 1 if I only have one of that elements, right? How many OHs did I use? Well, I used 2 OHs, right? So I used 1, 2 OHs. So OH 2. But notice that if I use 2 OHs, And I just put this 2 on the bottom right-hand side. It signifies that I only have 2 H's and 1 O, which is not true. I actually have 2 O's and 2 H's. So to show that I have 2 of them, I'm going to put a parentheses around the OH, right? And then I'm going to put the 2 on the outside. So this is kind of like the distributive property in math, right? So like 2 times 1 H is 2 H's. 2 times one of these O is 2 O's. So it kind of shows me that there are 2 OH's, not just 2 H's. So I just erased the arrows for neatness, and this would be my final answer, right? So this would be my formula given this name. So MgOH in parentheses 2, because I have 2 OH's that I used. I want to mention a couple of things: that you only need a parentheses around the polyatomic ion if you have more than one of them. So if I just had one OH, I don't need the parentheses and I don't need the subscript on the right-hand side, right? And if I have 2 Mg's, this is not a polyatomic, so I don't need to show that they go together, so I don't need a parentheses. So key thing to keep in mind, that you only need a parentheses around the polyatomic ion if you have more than one, right? So these are the 3 steps we use to solve, and let me do one more where we don't need the parentheses, just so you can see. Okay, so for this next problem, I'm given the name lithium carbonate, and I want to try to figure out its formula, right? So same thing as before. I'm gonna go ahead and look up the charge of lithium on my regular periodic table, because I know this is a regular element. And if you can't tell that it's a regular element, in general, the first element is usually a regular element or a monatomic ion, your usual ions that we've been practicing, right? Okay, so clicking onto the regular periodic table, I'm going to look for lithium. Here it is. Its charge is 1 plus. Right? So lithium is going to have a charge of 1 plus. Right? Still on step 1, I need to find the charge of carbonates. Notice that this ends in 8. So remember that whenever an ending is in 8, ites or side with an X usually tells you that this is a polyatomic ion. So that means it is not on the regular periodic table. Therefore, I need to look at the polyatomic ion chart. So I'm going to look for the word carbonates, right? So I'm going to scan through looking for the word carbonates. None of these. Aha, here it is, carbonate. So that is CO3 with a charge of 2 minus. So going back to the problem, I'm going to write down CO3 with a 2 minus charge. So now I'm done with step 1. Step 2, I'm going to add up each element's charge until they combine to 0 or they have the exact opposite, is another way of thinking about it. So I'm still going to do these in the same 2 colors. All right, so this time my charge of this is 2 minus and my charge of this is 1 plus. So because 1 plus is smaller, if I just add one more, Li1 plus, right? Positive 1 plus positive 1 is 2 plus. And just one of these carbonates already adds up to 2 minus. So see how my charges are the exact opposite. So this is positive 2, negative 2. They're the opposite, so when they add up, it's going to be 0. So now I'm going to move on to step 3, where I'm going to identify how many of each element I used. Right, so here I had to use 2 Li's. So my formula is going to be Li2. Because Li is just one element, it is not a polyatomic. I don't need to put a parentheses around Li. And my second ion, CO3, I just use one of them. So it's going to be CO3. I don't even need to write the number 1. And because I only need one of them, I don't need to write a parentheses. So this would be my final answer. Okay, so what if I had to do the opposite? So how do I find the name if I have the molecular formula of something that has a polyatomic ion? So here, identifying the 2 ions, this one might be kind of tricky because you might not know where it splits up, right? So what if it splits up here, or maybe it doesn't split up there? Maybe it splits up here or something like that. How can you tell? Well, in general, a quick tip is that the first element is usually your single element, and then the rest is the polyatomic ion. And the more of these you end up doing, you'll tend to be able to kind of intuitively identify the polyatomic ion, right? But in general, the first element is by itself, and then the rest is the polyatomic ion. So here, N is capitalized, A is lowercase, so Na will go together as one element. Right? And I'm going to guess that the rest, C2H3O2, is my polyatomic ion. So whatever the name of Na is going to go here. And then whatever the name of the polyatomic ion is going to go here. So rest is polyatomic ion. First elements is the single elements. So if you don't know the name of Na, you're going to pull up the regular periodic table because this is just one element. And you're going to look for the elements Na. Okay, so we cleared the periodic table up. So looking for Na, see the Na symbol here? And the name is sodium. So it says sodium underneath. If you can't see the name, feel free to click on this, and then that way you can zoom in and zoom out. All right, so Na is going to be called sodium. So going back onto my regular periodic table, or sorry, the problem, Na is sodium. All right, and then for C2H3O2, I'm just going to look this up on my polyatomic ion chart. Right, so I'm going to look up C2H3O2. C2H3O2. So notice that this time, if I'm looking up the formula, just looking up the second half, right? This part here. So I see C2H3O2, not this one or this one. It has the charge, but you can ignore the charge when you're searching for the molecule, right? Or the polyatomic ion. So C2H3O2 is called acetate, right? So then I'm going to add that onto here. Sodium acetate. Right, so this is how I name polyatomic ions. Very straightforward. I don't need to change the ending if it's a polyatomic ion. Everything stays the same. So I just find the name of this, find the name of this, and then I'm done. So at this point, you should be able to identify the quiz problems and work on those on your own. If you do have any questions, feel free to message me in the chats, or I will go over the stuff the next day.